Into the actual link configuration of the training. Before we start, we're going to cover a couple of scenarios. On microwave radio links, what can we actually build? Typically, we have a 1+0 system, just a point-to-point link, as we've been talking about in the morning. 1+1 system, hot standby. 2 radios are active at the same time, but only one transmits. The other one is only listening to the other side as well. So the RSSIs are symmetrical. Okay.
Same channel, same
exactly,
frequency.
correct.
2 identical radios.
2 identical radios.
It's like hot standby radio protocol.
There you go. The only thing is the other one is not transmitting. So when you have the 1+1 failover, between the radios there's a physical connection, and that is to keep alive literally a bit. When one fails, the master fails, and the slave does not detect the other master unit, it will actually start transmitting.
Is that a hitless switch, or how long of a?
It's hitless, so it's really fast. I mean, it's literally, it's the keep alive, it's always constant, so you won't really see it. Now, on the 2+0 system, on 2+0s, I want to touch a little more in depth here. 2+0, it's aggregating the actual capacity of the links. Now, here you have 2 independent links next to each other. That's a 2+0 system on a link aggregation protocol, LACP on the network side, not using the actual radios to aggregate anything. Now we have PLA and Xfig. Difference between 2+0 systems and PLA. The 2+0 system is 2 radios side by side, double the bandwidth, and native redundantly. Okay? If one goes down, you still have half the throughput. On the PLA system, it's convenient because you only have one cable coming down the tower with your full amount of 800 megs. However, as John said before, if the master fails, that link is going to go into the slave, and it's going to be a 1+0 system literally. Okay? Now, on the PLA, to make that happen, you need to use routing on your switch to be able to switch traffic. So you get a little more cables as well.
On which one? PLA?
On PLA, yes.
Well, PLA works without it, unless you need. I couldn't quite. I was trying to follow that exact circumstance.
So here, it's okay. So let me go through it again. So in PLA, you have a master and a slave, right? So master forwards the traffic for both radios. So you have a management cable and then a data cable. On the slave unit, you're going to have the same thing, a management cable and a data cable. The data cable is literally just a standby path. Okay, it's not forwarding traffic. Everything goes through the master unit. When the master fails, it goes to a 1+0 setting. The slave says, there's no more PLA, I'm forwarding traffic. At that point, OSPF or span entry kicks in. I don't have any path going through here. I'm going to my secondary route. And you go ahead and forward traffic.
Oh, so you could still use something like ether channel or something. So basically, we're doing switch side.
Correct.
Load. Okay. So that's only if master fails that you need that. On a normal day, a slave, you only needed one cable.
One cable, yeah. Actually, people implement PLA without failover as well. So, but they rely on just that master radio. Okay. Now this is handy because sometimes you have providers that only say, well, this is my company, I only have one port for you available. Only one port. So okay, how am I going to deliver to this customer 800 megs? It's a gig port connection. So I can come down with a PLA connection, you can hand them 800, 700 megs. Here you go, in a single cable connection. Again, 2+0 on the network side, 2 ether channels, and you're done. And you only bond the data. You do not bond the management. Now, when we talk about 1+0 and 2+0 systems, we got to remember something. When we talk about 2+0 systems, we always recommend using out-of-band management. Okay? If you use in-band management, you're going to get management conflicts. Okay? So, our best way of doing this, you can do 2+0 PLA that must be done OBM. On 2+0, you can have 2+0, 3+0, 4+0, as much as your wallet can afford. The management is always going to be independent. Okay?
And it's nice to have out-of-band management because if you make a mistake on your settings on your distant end, you avoid that 6-hour truck drive.
Correct. Yep.
Well, if you're going to be that paranoid, you better have the terminal. You better have the console port wired up.
That's right.
Yeah.
Cellular
modem. Yeah, and you can have the you can actually have the serial going to the ether nowadays. So you're still good. Now, PLA, again, link aggregation, right? Physical link aggregation. Xfig. What is Xfig good for? Xfig is to use the same frequency and same channel on two adjacent radio links. This is for metropolitan areas, for example. Chicago, New York, where there's not available spaces on frequency bands, you can actually use single channel on two radios, same frequency. They won't interfere with each other. What would happen if I put two identical links next to each other, same frequency, same channel? They will interfere with each other, right? Natively. Now, Xfig mitigates that. It's cross-polarization, interference cancellation. So what's going to happen is, if you light them up next to each other, the MSE is what's going to happen? It's going to go really low. You're going to get 15, 10 MSE, because you have interference, self-interference at that point. When you enable the Xfig feature on the radios, the MSE symmetrically are going to come up to the same MSE value, either in the 30s or 20s. Okay? Depends on the actual link line. Any questions on the setups on the links?
So does Xfig increase the bandwidth then? Or is it just for
2+0 setting? Xfig is more for when you don't have the frequency spectrum available. So it really has to do anything about capacity. It's more about spectral efficiency.
When I ordered when I thought I was getting a 60 meg channel, but it turned out I was getting a 30. I need a stick.
That's where I get confused with it, because I think it's double the bandwidth, but it's not. It aggregate across both polarities.
It's letting you use the same freak on two polarities.
On two polarities,
Yes.
right.
But you can't. You still need two radios.
You still need two radios.
If you want to use the same in horizontal vertical, you need two radios.
Two radios to that. Yes.
And that's the max throughput of 761 or whatever.
You aggregate those two. You basically got two links at 761 basically at that point.
Two
at 761, so
Yes.
then you get
You
basically a gig and a half.
Close to a gig, yes. 9 something line rate, so TCP. Yeah.
Oh.
Physical connection limits the 1 gigabit port as well.
Yeah.
So, but here, what I want you guys to just learn about the actual concept, right? 1+0 systems, in-band management, no problem. Single cable carries management and data, and power as well. If anything besides any 1+0 systems, PLA, Xfig, 2+0, 3+0 has to be out-of-band management. That's the best way to go.
So 2+0 or bigger, go
Yes.
out of band. Yeah.
Out of band, exactly. Some customers actually do 2+0 with IBM, and the first thing they tell me, look, I cannot get to one radio or the other. They make a loop on a lot of those switches.
Mm-hmm.
So that's what happens.
Are you guys defaulting your radios to not be set on a VLAN, management VLAN when you ship now?
Yes.
Okay.
It's set now.
First few we had that set, and wasn't written down anywhere, and we're like, is this really dead out of the box?
No, yeah. So the default settings out of the box are always going to be IBM with tagging off. Yes.
Yes. Okay.
Yeah. If not, if for any reason there's a VLAN there, you can always do a hard reset on the radio, and it will go back to factory defaults. And that is the actual factory, IBM with tagging off. Any questions on the configs? 1+0, 2+0, PLA, Xfig. We're a small group, so we can actually get more hands-on time. So we're gonna try to do right now a 2+0 PLA if we can. Right now, this set that I have in front of you guys, all of them are out-of-band management. The reason why, because I have into the same physical switch. If I use IBM on all radios with the same physical switch, that's going to be a really fun loop. So when you test them on the bench, the first thing I recommend is put them next to each other and go on one side over the air to the far side. That's the way you test the actual links. Okay. Questions on this? Scenarios 1+0, 2+0.
So, Xfig, the PLA is used in conjunction with Xfig.
Yes, you can.
Okay.
You can, but you're not required.
Correct. I mean, you can. PLA is a feature in all the alliance links, so that's.
Well,
no
I
problem.
think we use it in conjunction with it, if I'm not mistaken.
Yeah, you guys have Xfig and PLA because you have the Xfig cables and you have the IDUs, I think, the split system.
Yes.
Yes. So again, for installing purposes, so you guys talked before. If I have an all-outdoor radio, which is the Alliance, on my combiner, I don't have two radios, but I want to have a bunch of cables going between each other, right? In the indoor units, I only have a small amount of cables going between the actual patch mount. And for troubleshooting purposes, if something were to burn out, short circuit, or just it's acting really weird, you can just go to your shelter, swap out the IDU, and you're done. With this, you have to climb the tower. So, also, ease of use, right? If you want to install less than 250 feet, Ethernet run, you can do that with all outdoors. If you need to go higher on the tower, you have to go with a Lamar cable.
Right.
The other option is with the all outdoors is to run DC power and run a fiber jumper all the way up to as high as you want to go. Pretty much with fiber. Radio features. I know this morning you guys are expert now at this. You cover every basis, but we're going to go over them again, okay? Hitless ACM, adaptive coding modulation, out-of-band management, in-band management, 1+1 hot standby, PLA, Xfig, rapid port shutdown. That can be good and also can be bad. I'm going to explain why as well. Okay. Now going to the list here, there's out-of-band and in-band management. I know that a lot of you guys have Giga Pluses, for example, right? Well, in our previous models, Giga Pluses, you had 2 IP for management. Okay, you have the in-band default management and a specific out-of-band management port. On the new products, the Orion Links, you only get 1 IP. Okay, so you have to choose on GE1, the primary port, is it going to be IBM or OBM? That's the only thing that changes moving forward. Traffic-wise, I'm going to do a little more explaining as we go along. Hitless ACM is the ability of the radio to downshift and upshift modulation based on the conditions of the actual weather. Okay, if you have bad weather going across the link, if there's thermal inversion, as we said before, if there's really hot temperatures, especially for us, for example, in the Middle East, right? We have links going over the desert. What happens? In the day, they're super hot, right? It gets over 100 degrees, really scorching weather. When it start getting dark, it gets cooler. In that middle point transition with the hot and the cold, the RF just goes like up and down, and you will see it. If you monitor the link, you will see the RSSI go up and down, up and down. You're like, what's going on? Is something failing? My power supply is gone, my ODU is going bad, what is it? No, it's actually ducting because of reflection for thermal induction. Now, the radio, ACM, goes up and down by itself. In the Orion Link series, you cannot turn off ACM. ACM's on by default. In our previous radios, the pluses, you could enable ACM on or off. Good things and bad things. In the previous series, if you did not enable ACM on both sides, you could have the greatest link in the world, but what happened? It did not lock at all. Okay? In this one's, ACM is always on, so there's no problem with that.
So they told us initially, because we have pluses.
Okay.
They said to have ACM off while you're aligning it.
Yeah.
And then turn it on when you're done. And I mean, I turned it on remotely and I didn't get bit. Turn far end on, near end on, and that seemed okay. Are we just thinking different now? Like we don't care?
No. So now we have. In the past, you had a fixed modulation speed channel, right? So ACM went up and down, and before you had speed, channel bandwidth, and then your modulation, your fixed modulation. In the new radios, you have a max modulation and minimum modulation rate. So now the radio can play between those modulation rates. Before, you could not limit the radio to go up and down a certain amount of modulation, either from 512, so 256 to 32 QAM. Now you can. Some people prefer to do this. I have a 1024 QAM link, and then if it goes down to 32 QAM, I'd rather drop the link and use another path. That's based on what the application you have, exactly.
Set thresholds.
Correct. Typically it's from QPSK. When you align the new radios, you can set both the min and the max to QPSK for alignment purposes. After that, then you can go back to 1024. Okay? But yeah, it's just correct. When you do any changes, typically when we're the far side, then the local side. Then you don't get bid back. Any questions on ACM? This is a feature out of the gate now on SM24 and Orion Links. ATPC, automatic transit power control. This goes hand in hand with ACM. Now remember, rule of thumb, higher modulation, the lower power I need. the lower modulation, the more power I can put behind the radio. So at 1024 QAM, our power is going to be anywhere from 20 dBms data sheet spec, and at QPSK I can go way higher, okay? Because it's a stronger link. If I don't have ATPC enabled, what's going to happen is ACM is going to go up and down with the same transmit power, okay? It is effective, but it will be better if going down, the radio has more power behind it. Now, one thing to note, more power is not always the best. A lot of times when people get the links for the first time, they set them up on the bench and they crank the power all the way up, right? I want a 1024 QAM at 26 dBms of power, right? All the way up. And I get a call, hey, I get BERs from this thing. The ODUs are bad or something. Throttle the power back a little bit, and then you'll see there's no BERs. Actually, you can overdrive the transmitter if you have too much power. And that's also in the field. With the unlicensed product, the SR24 is really common. You can only go from -20 to 0 in the United States. -3 is the legal one here. So in 24 gigs, you have 1 mile point-to-point link. You want to crank it all the way up to 0, and you start having problems. Your MSC goes down, you have BERs, the signal goes up and down, RSSI, because you're overdriving the transmitter. That is a problem. Now here, this is to know that, again, on our microwave radio links, it's not always good to have max power. Has to be depending on the modulation rate you're going to use. Rule of thumb, higher modulation, less power. Lower modulation, more power behind it. Yes.
If you take these radios and you run them without an antenna on them, do you risk blowing the finals in the radio?
No.
No, these don't have
No,
that.
you need to load at the end or nothing. It's fine.
It's so low because the transmit power is just generally low anyway.
You can keep it down, yeah. For
Okay.
example, in this note that I have for you guys, so this is a bench test, right? This is called the poor man's bench test because we don't have any antennas between them, we don't have anything. But I have a really neat trick for you guys. Right now, if I turn it on, we're gonna have a -10, -5 RSSI in this link. That's not really good. The radio needs to operate at least at -24, we recommend 30. That's as high as you can actually run. Anything below that, you're gonna see BERs and FERs. So try to keep it on the 30, they're usually engineered for that, 30 and above, 34. In the middle, if you put stacks of paper, it's a great attenuator. And I'm gonna bring forward so you guys can see the actual effect on it. The other thing is to do is just put them apart, 3 or 5 feet apart. But you get a lot of bounce and reflection because it's just an open waveguide. So just a sheet of papers, they work really great. So back to your question, no, it doesn't harm the radio if you have it just powered on.
So if even if we're not using ATPC, it's still okay. You're not going to hurt the radio.
No, you're not. So you, for example, you can turn it on, leave it on the lowest power. It will be leaking RF, yes, but it won't damage anything.
But even if it was on highest power, it's not going to hurt it.
Nope.
Okay.
You will just say your MSC were really bad. That's all. Now, ATPC, as we said before, each modulation has a specific transmit power. In this case, this is for a QAM 256 radio, which is our Apex Plus models. You can see this table. I'm going to step down 2 dBms at a time. ATPC power for QPSK is 25 dBms. As I go to QAM 16, 22, 32, 22, and I'm going to keep dropping power as higher modulation I go. Where do I get these values, by the way? Okay. Based on the data sheet of the product. If you buy an HP2, HP3, it's going to tell you right there what is the max dBms transmit power per modulation. I believe out of the factory, these are not set. They're all set at 15. I think that is the way they go out the door. Unless you enable ATPC, I think we can configure them for you. Radio management, okay? Always the best topic. Out-of-band management, okay? Out-of-band management is dedicated port for management traffic only. As we said before, new radios, Orion links, GE1 is always a management port, out of the box and natively. If you do a hard reset on this radio via the push button, everything is going to go back to default. Management is always on GE1. Even if you change IBM or OBM, management is centric. It's still on the same port, GE1. Unless you change it, but default is GE1. Okay. When we have out-of-band management, we pick G1 to be our management, and we still have 3 ports for traffic. Well, obviously, on our all outdoors, we only have one or the other. G1 is going to be either management, and the SFP has to be used SFP to copper or fiber for traffic. Now, for traffic purposes, on the Orion links, untagged traffic will go natively across the link with no problems. So if you have untagged on your network, you don't need to do anything else. But if you have any VLANs going over the link, you have to add them per port, okay, for traffic. Yes, I know that face. Yes, but I have a little trick for you guys down the line. Don't worry, I know. Apex Pluses didn't do this, Links and Orion did. I have a little trick down the line. You're gonna like it. This is gonna save you a lot of trouble. Okay, inbound management is the ability to manage the radio and pass user traffic on a single cable. Now again, G1 is going to be a management port and traffic port. On the all outdoors, G1 is the same thing. Any questions on management? Because typically this is where people get a little bit more confused. What do I use? Out-of-band or in-band? Really, it's up to your application. Think about this. If you use IBM in a 1+0 system, as long as you have a link going across the air, you can always get to the far side radio. If you use OBM, you have to get to the far side radio, jump to the switch, and then come back to the radio basically using OBM. So it's up to you. If you have a redundant path to the tower, I would suggest using OBM so you can always go back to it in case something happens. Okay. Yeah.
When something happens.
Yes. When it is the nature of the business, right? It is a wireless connection. So it's up to you guys really. You want, yeah.
So, but you said in your newer software you went away from having 2 IP addresses?
Yes.
Why?
If I could have any power on that one, I would have just kept it at 2. I like the actual 2 management option for it. Right now it's for management efficiency. So before, having a separate management was great, but moving forward, inside the radio, it's a switch, literally a layer 3 switch. Mm-hmm. So you're port mapping a lot of traffic, what comes in, put a special VLAN on the end for untagged traffic and forward across. So it's moving forward most efficient for us using a single IP. But yes, I do hear what you're saying.
So if the Ethernet interface is down, that's on the OBM Ethernet interface, if it's down, can you still get to it over RF remotely? Okay. And then they take away the other IP.
Yes.
Take them to the woodshed.
Yeah. The only thing there is you
tell
only
them to go to the top of the mountain.
Exactly. Yeah. Trust me, I had this discussion with our software team, guys. Can we take a field trip? Because they have to go out there. I mean, the position of the customer is this is going to be in a mountaintop, remote areas. So if something fails, you got to have a backdoor to the radio. So unfortunately, yeah, you only have one back.
So they just say go get a console port and a cellular modem and shut up.
Yes. Yeah, that's what you got to have, the console ports. And remember, in the all outdoors, it's just a 2-foot cable, so you got to bring the radio down as well. So moving forward, your decision can be based on that as well. What is your feasibility for troubleshooting? How fast can you get to a site? What accessibility are you? Field guys typically they carry a laptop, a USB. What are you going to give your field crew as well? So OBM, IBM. Any questions or applications? Out of the box, everything is IBM. Remember that. And when you factory default the radios, if you have OBM, but you factory default them, it goes back to IBM. Remember this, because if you're on a tower site and by any mistake you're going to have an outdoor model and you push that push button for 4 seconds, it's going to go back to IBM. Okay, so at that point, all your VLAN settings on the switch, all your routing, all the cables coming down are going back to IBM, not OBM. Okay. Apex Plus, Giga Plus model, just to recap, we have 2, all outdoors, we have 2 Ethernet ports, one for management, which is only 100 base, and then the gigabit port for traffic. Both are PoE, so you can either power the management or the data port. And on the Giga Plus, you have your your T1s and E1s. Again, 2 Ethernets and 2 SFPs, plus your management port. Okay. Now this product is still around, but it's only pretty much for people that use TDM applications, E1 and T1s. Moving forward, you only have a single Ethernet connection that can be either IBM or OBM, as well on the Giga line and links. Now you have 2 more ports, 2 SFP ports. As well, management is always on GU1. On the SL24, same scenario. Now management is still the same across all platforms. It's still going to be on GU1. You can decide either IBM or OBM. So just to show and tell here, so this is a licensed radio, right? It's 2-part radio. There's the OMU and the ODU. The OMU is the smarts of the radio. This is what tells the IP, SNMP management, syslock, this back part where the ports are. The ODU itself is just a piece of metal that tells you the frequency of your transfer radio. So in case you can change this piece of metal and go from a 6 to a 23, 11, 18, this is what dictates the actual frequency, not this. Now, licensed gear, SL24, unlicensed gear. Still microwave, but anything different? It's a single core radio, right? So this cannot change anywhere but only 24 gigs. So this is the difference between a licensed and unlicensed gear from chaim. So it's a single piece. Again, vertical, horizontal as well, I mean alignment purposes, but a single casing on a radio. This cannot be swapped out for any frequency else. It's only 24 gigs. One thing to know on this 24 gig radio. On the market, a lot of people tell you 24 gigahertz gigabit connection. Yes, but they're Ethernet based. This one has a fiber port. So what does that mean? I can go further up on the tower, or I can go longer distance from my NOC, from my shelter. You're not limited to that 250 or 300 Ethernet based. So you can actually put a fiber port and use DC power and take it all the way to 200 feet or 300 feet up in the air. So it's a really good rate. But I want you guys to show you the actual single core design and how a license has the actual ODU that determines the frequency. So for starting purposes, if you have an SL24 link, you have to have another one of these. And it doesn't care what frequency it is, you can always hardcode the frequency. For the licensed radios, you must have a spare ODU for each side. I'm going to go into detail why this is. Any questions on OBM and IBM? I've been going again and again at this because this is one of the most important topics I get a lot of questions on. What do I use for management? Okay. 1+1 has standby failover mode, as we said before. You have your main link, which is transmitting and receiving. But the standby link, it's just receiving. It's listening to what's transcoming from the far side. So when you log into it and do RSSI link test, you should see the fairly symmetrical RSSI. There's going to be a little bit of off depending on the combiner, but it depends on frequency as well. That redundant cable, if it's not there, there's no point. That redundant cable sends the keep alive to the other radio, the slave radio. Now, when do I do, what is 1+1 hot standby good for? In case, what are the use cases that we have? Manual switchover. Now remember, the 1+1 does not aggregate the actual throughput. It's a single link, so it's 761 across, and you have your backup, which is again 761. What is it good for? If I need to reboot my master radios, I can go ahead and reboot them without any problems. I will still have a service going across the link. If my ODU cable gets disconnected, if for some reason somebody goes to the tower side and start looking at the ODU, unplugs it, thinking it's the correct IDU, it will go down, but again will kick in. But there's a link loss. Yeah, there's actual RS link loss, it will come up as well. Power supply failure. Now, of course, for this you want to have independent power supplies and different sources as well. A reboot. What if I want to reboot the radio because it has uptime of 400 or 660 days, for example? It's a telecom equipment, it's a computer basically, it has a switch inside, it needs to be rebooted once in a while. I've seen radios that have been chugging for 700, 600 something days. No firmware upgrades, no checkups, nothing. They're going strong. However, it's always recommended to have a maintenance window just to make sure everything is running fine. Okay? PLA, physical link aggregation. Again, I want to touch bases on this. Two radios aggregate each other physically without the need of LACP on the switch. What is it good for? If you want to deliver a service with a single cable for 800 megs. The way it works, it comes into the master unit, the master radio, the PLA master, splits traffic, and then goes across the link on a single string. I'm going to show you this later on. Rapid port shutdown. Why did I say this was good and it is bad as well? Now, if rapid port shutdown is enabled, if the link is lost, you can set a threshold for it to shut down your data port. But what happens? When RPS kicks in and the port shuts down, you cannot go in there and manually turn it on. You have to reboot the radio again, power cycle, to get the data back on. This is good for not forming loops. However, if you have it set up correctly, OSPF can be your best friend or spanning tree. Okay? That's why I say this could be good, this could be bad. I prefer to turn RPS off. Okay? I'd rather rely on my spanning tree on the switch to do the actual routing. Threshold configurations. Now this is what actions can I use on the radio. If my RSSI goes -85 to -20, there's 4 options, like 5 options you can use. First, do nothing, basically. 1, set an SNMP alarm, a trap. 2, another alarm. 3rd, SNMP trap manager. 4, do a switched over. 5, shut down the data port. So this is on the radio itself. So, web configuration. Before I continue, any questions? No? OBM, MyBM, ATPC, PLA, Xfig, all that? Okay. Well, I'm going to give you guys 5-10 minutes just to wake up a little bit, okay? So you can just come back and just actually do the web config, okay? And CLI. You can sit down.